Hello. So today we're going on to Similarity Part 2, which is about triangle similarity. Here we have the symbols for it. Triangle is the first one, and then this little tilde means similarity. Okay. Last time we were looking at general similarity, which means that the shapes will have congruent corresponding angles, so all the angles are the same, and proportional corresponding sides, which means that every side has the same scale factor. Okay, we have consistent scale factors from one shape to the image. Okay, I want to make a note that corresponding is the application of that side angle relationship. Okay, so an angle corresponds to the side that it opens up to. It's across from that angle. Cool. Okay, so checking all this sounds like a lot of work. Even for a triangle, there's 3 angles and 3 sides, so that'd be 6 things to check every single time. But the nice thing about triangles is that we're learning we only need to check one of those aspects. We only need to check all 3 sides or all 3 angles. Okay, so triangles saves us a little bit of time. Either of the two is good enough. Okay, so hopefully you relax like SpongeBob over here, enjoying the fact that you don't have to do all 6, just half the amount of work is sufficient. Okay, so with the angles, if you're checking the angles, this is called angle-angle similarity. Okay, angle-angle similarity, AA with a squiggly afterwards. You can see that down here. The rule is if 2 triangles have congruent corresponding angles, then they will have proportional sides. Okay. The question is, why do you think that we only need 2 congruent corresponding angles to show that all 3 of them are congruent? Okay, so I'm going to give you a moment to reflect on that and write down your response down here. Cool. If anytime you need more time, feel free to pause the video. Hopefully you said something about the triangle sum theorem, meaning that if we know 2 of the angles, for instance, let's say they add up to 100, then the third angle would have to be 80 because the 3 angles together have to make 180. That is a triangle sum theorem. So we know all 3 of them if we only know 2 because of that triangle sum theorem. Cool. And the next idea is, what if we just have the sides? We call that side-side-side similarity. Okay, we have 3 sides in a triangle, so if they're all proportional, then we can guarantee that the angles will be congruent. Okay, and this is just a spit in the dark here. Why do you think that having 3 sides being proportional will guarantee that the angles are congruent? Just a shot in the dark here. Any ideas? Okay, to me, this one's most clearly demonstrated after a few examples. You can see quite clearly that if you have 3 side lengths, that there's only one way to connect those 3 side lengths to make a triangle, and they're always going to be congruent. You can have 1,000 people with, for instance, a 3, 4, 5. If I give you a 3-inch thing, with a 4-inch thing, with a 5-inch thing, and I tell you to make a triangle out of those 3, where the endpoints connect nicely, there's only one triangle we would all be able to make, and it is a 90-degree triangle. Okay, so it guarantees that the angles will line up if the sides are proportional. So here's some evidence. This one we're going to go through, and our job is to move these around until you're comfortable. You can flip it over if you want, but I just want to make sure I can see the numbers on here. Okay, and we're going to do these 3 things. Ooh, that ordering I just noticed is off, but it's okay. So we're going to pick an angle, and we're going to mark down that angle size right here. So I'm going to pick the 80, and then we mark it in the table. We're going to mark the proportion corresponding to it. So the 80 here is across from 8.1, and the 80 here is across from the 6.58. This fraction here tells me to do big over small. So I'm going to do the bigger number, which is 8.1, and I'm going to make it over the 6.58. And what we're looking for, if they are similar, the angles will all be the same, which they are already, then the scale factor should also be the same. Okay, that's what we're trying to show ourselves here. Next one I will choose is 56. The green triangle is bigger, so I'm going to use the green triangle, which is 6.79, over the small triangle, which is, so I'm looking for the 56, 5.51. We'll start understanding why that side angle relationship is so important here. Notice that the 1.23, 1.23, I'm going to ignore the rounding on that. And the last value here is 45. 45 is across from 5.78. And over here, the 45 is across from 4.69. And once again, we have 1.23, 1.23. All of these have the same exact scale factor. If we round, the reason why that's happening, just as a side note, is because these values here were rounded by Desmos. And so the scale factors are a little tiny bit off because of that. It's rounding errors. Okay. Okay. So that was our goal. We noticed that these three angles are the same. These three angles are the same. So 80, 80, 56, 56, 45, 45. And that guaranteed that our proportions would be the same from one triangle to the other. Okay, that's what we're looking at here is we're trying to prove to ourselves that if the angles are the same, the sides will be proportional. Okay, so I'm going to ask you to do that one more time down here. To do that, move your triangle around so that way you can get different numbers. But notice that the angles will be the same, and when you divide your numbers, you're going to get the same result over here. It's not going to be the same exact value here. It's not going to be the same scale factor, but they will all be pretty much the same number. Okay, so I'm going to give you some time to do that. I recommend pausing, and then once you're done, you can unpause and we can keep talking. All right, so hopefully you paused and you were able to finish that. Some things to notice, okay? As you changed it, did the angles move? No, the sides changed, okay? And then each example, within this example and the one you created, hopefully your scale factors were consistent, okay? Hopefully your scale factors were consistent, which is what should happen. What this is supposed to show you or give you a chance to notice is that with any two triangles, if the congruent corresponding angles, then they're going to automatically have proportional corresponding sides. Okay, the converse is also true. Okay, so that we didn't explore that really, but the converse is also true. If two triangles have proportional corresponding sides, then we can guarantee that the angles will be congruent. We do not need to check both. That's the moral of the story here. This is the last time we're going to have to check all of it for one problem. Okay, so now we get to check either the angles or just the sides. We don't have to check all 6 things going forward. Cool. All right, so let's do some practice. So in geometry, similarity means that shapes have congruent angles and proportional sides. Okay, but for triangles, we only need to verify one of these things. So here, we don't have angles, but if we can prove that the sides are proportional, then we know that the angles are going to be the same and these shapes will be guaranteed to be similar. So what they have us doing here is the reference angle C, okay, goes to the medium side, and it corresponds over here. I got to find the medium one. So the biggest one is 4.8. The medium one looks like it's 3.84. So C corresponds to F. Okay. And so now I have to do the big to small between those numbers. Which one's bigger? Looks like 6.528 is bigger. And then 3.84 is the smaller one. And it gives me a little check to make sure that we did that correctly. Okay. So I'm expecting that those scale factors will all be 1.7. Okay. If that happens every single time, we can say that these are similar. If it doesn't, then we're going to say no, they're not similar. Okay, the angles will not be the same. Okay, so A goes to the biggest side. Everyone see that? So this one points over there. The biggest side over here corresponds with T. So I'm going to put a T there. We're going to do big to small. So that means the red one goes on top and the blue one goes on the bottom. Notice I'm being consistent. Okay, so A goes to T, and so the biggest one goes on the top, smallest goes on the bottom, and I'm going to ignore that and try to fix it for when you guys get to it. But notice that the 1.7 matches the 1.7, so that's what we're expecting. And then likewise for B, B goes to the 5.7, which is the lowest number. And then the smallest number looks like it's going to be V. So V corresponds to this. So once again, we're still doing the red over the blue triangle. So the red triangle is 5.712, and then the blue triangle is 3.36, and then notice that's also 1.7 there. Okay, so that's good. Okay, so even though we didn't get the check marks, you guys should get the check marks because I should fix it by the time you get to it. Okay, so because these angles look like they're gonna match up, I don't even know what they are, but that's the order that they would be in. We know that they have to be the same because these scale factors are the same. Okay, so they have to be similar. Okay, and then the question here is this scale factor, does it take us from a small number to a big number or from a big number to a small number? And because we're multiplying by a number bigger than 1, it's going to make it bigger. So this one takes us from a small to a big. All right, let's look at the next page. So once again, the rule is that similarity has to have congruent angles and proportional sides. Okay, if that does not happen, they are not similar. Okay, but for triangles, we only need to verify one of those two. Okay, so we're going to determine if triangle TVF is similar to ABC. And to do that, this time they gave us angles. So notice they gave us two angles here, and they gave us two angles down here. They're asking us to fill out these angle measurements. So if you haven't already, please pause and fill out these angles. If not, you can follow along with me if you need to. Okay, so CAB is the angle down here, and that angle is actually missing. So we have to do some calculation. I know the three angles inside of a triangle have to add up to 180. So when I subtract those from 180, we get 44.7. 44.7. And that lets us know we did that correctly. ABC goes the other way. So A, B, and then C. So that looks like it is 35.5. And then the last one is BCA. So B starts here, C, and then A. That one is the 99.8. Looks like we did a good job with that. Thank you, Desmos, for letting me know. And then we're going to do the same thing for the other three. FTV. FTV is there. So that one is 45.4. Noticing already that these aren't going to match because that says 45.4 and this says 44.7. Those are different. So automatically these are not going to be similar, but we're going to keep going so we can get the practice. Okay, so TVF is the next one. TVF. Yep, TVF looks like it's 39.8. And the last one is VFT, which is down there. It's the one we do not have. So I'm going to use the calculator, 39.8. 45.4. And that calculator gives me 94.8. Notice that these values do not line up, and so there's no way that they're going to be similar. Okay, so no, they do not match. And then we can look at this and it actually throws it there and shows us that no, they don't line up nicely. Right, so it's a little bit off. Cool. So we've seen two examples. If the angles don't match, then the sides will not be proportional. So we don't even have to worry about looking at the sides here. Okay, if you have not already, press pause and try this one on your own. Okay, so this one, notice that we only have the sides of the triangles. We do not have the angles, so we have to show that these sides are proportional. To do that, we have to figure out which sides are corresponding to each other. So we look at the angles for that. So 17 looks like it's the biggest one, so C corresponds to the biggest side. Okay, so the biggest side over here looks like it's F. A corresponds to the middle side. The middle side looks like it is T. And then B looks like it's the smallest side. So that means that it would be V over here. Okay. So C corresponds with F, A with T, and B corresponds with V. And if we do the fraction, we would get, so C is across from 17.136 and F is across from 10.08. And nicely check that again, thank you. A is across from 10.71 and T is across from 6.3. Oh, I did not like that. And once again, I know that these are lining up nicely, so it's okay. And then B and V. B is across from 8.568, while V is across from 5.04. Okay, so notice all three of these are the same number. They are congruent. That means their scale factors are consistent. Okay, and that lets us know that these are indeed going to have the same angles. Okay, and this scale factor, once again, looks like it goes from small to big because it's bigger than 1. You can compare them. Notice there, and then it gets a little bit bigger, and they do line up. Okay, we can say that they do line up there. Okay, so we kind of get the idea. I'm going to give you guys time to do this one. All right, so filled out those values. We can tell the missing value. For instance, we didn't know this one because the three angles have to add up to 180. Likewise, we didn't know this one, and we can figure it out because the three angles have to add up to 180. And because these match, we know that these have to be similar. Okay, I can compare them. That means that it might not be the same size, but if we make it enlargement, we can actually get it to line up exactly the same way. Okay, so it is proportional. Okay, so same thing. I'm going to pause mine and finish this one. Hopefully you will pause yours also as we go through this. Okay, so I found out that the three sides are proportional. Okay, let's see. Yes, technically not, because this one's a 1.3 and this is a 1.4, so be careful on that. Um, Rounding at the 100 spot or at the 1,000 spot is okay, but at the 10th spot it gets kind of iffy. So I'd imagine this would be a no. So yeah, they say that no, it's not exactly the same. So they are not proportional. Let's see what it looks like when we put them on top of each other. Notice it's already off on the bottom. We can see that the scale factor is not proportional, so it's not consistent, and it's not going to line up. Okay, so I was tricked in the beginning, but that's it. It's because this one is off by a little bit, they don't line up. Okay, so the scale factor is not consistent enough to make it similar. So the next part is not required, um, but it is an advanced topic. It's kind of another shortcut. So if you don't have all three sides or all three angles, you can still actually do it with one other way. And what they're trying to get you to see here, I highly recommend once again pausing before I go through this and see if you can go through the next few pages on your own. But they want you to see that even though the oranges are proportional and the greens are proportional, if I change the angles, yeah, then these don't look like they're going to be the similar triangles anymore, right? So I can move them around, and that triangle is not the same as that triangle. It's not similar to it, okay? So they cannot be, they can be not similar. It's possible. It's possible to make them in a way so that they are, right? But that did not line up, okay? Even though the scale factors is 1.5. Okay, on the next page, they add this little detail here, which is the angle in between them. To note, for instance, with the Pythagorean theorem, that's kind of like a giveaway to this, by the way. If I make it a 90-degree, we can start talking about how a squared plus b squared equals c squared, right? It's always going to be the same. A squared plus b squared equals c squared, and those will be proportional, right? I can find the third side here. If this side is proportional, this side is proportional, that third side will have to be proportional. It actually does work out that as long as I know that the angle in between those proportional sides is congruent, then they actually must always be similar. Okay, so this side angle side means you have an angle in between two sides. Notice how the angle here, let me try to highlight that nicely. The angle here is nicely in between the two sides that are proportional. So you do have to check the two sides are proportional, and you have to check that the angle is congruent. Okay, but if that happens, this is the third way to check to see if two triangles are actually similar. Okay, if you know that this happens, if you know that side angle side is a thing, then automatically all three sides have to be proportional and all three angles have to be congruent. Okay, so for example, here, if you haven't done this one already, please press pause. You're just deciding which of these three you're going to choose. Okay, we do not have three sides on each triangle. We do not have three angles or even two angles on each side. Just a note, we do have this angle matches this one, right? So we do have one angle in each triangle, but we do not have two. Okay, so we cannot do this one, but we do have two sides. And 3 times 10 makes 30. 6 times 10 does not make 15. So let's try the other way. 3 times 5 makes 15, and 6 times 5 makes 30. So there's our scale factor. We have a consistent scale factor of times 5. And we have that side angle side relationship. We have two sides that are proportional with an angle in the middle. Okay, so I just want to mark these out so we all see that. Okay, so this one is proportional to this one over here. And then this one is proportional to the one over here. Okay, so notice we have two proportional sides with an angle in between them. Okay, so what's the scale factor? We looked at that already. It looks like it's times 5. And the reason why we know that MSL must be congruent to UST, let's see, UST is the one right here, MSL is the one right there, okay, is because, what are those called? They're called vertical angles because they go across the vertex. That lets us know we did a good job. Thank you, Desmos. So we talked about how AA works just for triangles. Would it work for rectangles? She makes the conjecture that all rectangles are similar since they always have 90-degree angles. They should be similar. Do you agree or disagree? So I'll let you guys explore that one. Okay, so for instance, are these rectangles similar? Hopefully you disagree that they are not similar. And so this is an example of ones that would not be similar. Okay, so you'll see your statement from earlier here if you filled it out. I just want you to take a little bit of time to once again type in what similarity means to you at this point in our unit. Um, what does it mean about the angles and what does it mean about the sides? And then now we've learned about triangles, so maybe you can add a little bit more about our understanding of what's required to show similarity with triangles too. Okay, thank you. Hopefully this lesson's going well for you. Um, please leave comments to let me know how I can improve this video for the future. Okay, thank you.